So I am Javier Sánchez. I am the coordinator of the Hydrogen Transport and Conditioning area at the Aragon Hydrogen Foundation, which belongs to the R&D department. I am responsible of projects that deals with injection of renewable gases in the gas grid, especially hydrogen, but also others important such as synthetic methane or biogas. My role in hydrogen in gas grids project, those HIGGS project, is work package leader in work package 3, which deals with the build, assembly, commissioning, and in the end operation of our R&D platform. Our R&D platform is a testing facility in which we test actual components of transport grids under hydrogen atmospheres at high pressures, considering different levels of blend and also 100% hydrogen exposure to see how these real components of transport grids can behave under these new gas conditions. So the goal of the HIGGS project is pave the way to decarbonize the natural gas grids. And it is essential to pave this way to make empirical tests to see how real components, the state-of-art components in natural gas grid can behave when the scenario changes and we are transporting blends of hydrogen, natural gas, and even 100% hydrogen. In order to get this information, to see how the materials, the components, the equipment behave, what we have done in work package 3 is build a testing facility. This facility enables to expose these materials, these actual materials, to high pressures of hydrogen under different concentration levels. And this way we can get real information of this new behavior, and we can also feed it input to other work packages that try to continue this task and give these final recommendations to pave the way toward a smooth transition to a new gas quality in the grid. As coordinator of the hydrogen transport and conditioning area, I lead projects dealing with one specific part of the value chain of hydrogen, which is the transport. And my main tasks are related to this specific part of the value chain of hydrogen, which is the transport. I usually lead projects related to injection of renewable gases, not only hydrogen, but also biogas or synthetic gas into the grids and other kinds of transport. So basically my main tasks are related to leading research projects and always focusing on test benches. This includes the design, operation of these kind of setups in which we can simulate close conditions to what is expected in reality. Yeah, so basically I have had to face two main issues here. First of all is that our inspiration we could get belongs to demo projects that are related to injection but at distribution level. So we have to raise the operating pressure to high pressure grids, to transport grids. And secondly, the main challenge was also that we had to scale down the facility because we are not injecting in a real transport facility of the transport grid, but we have to prepare some kind of prototype, a big prototype. So scaling down, trying to reproduce a real transport grid, but at a smaller scale with lower diameters and so on, was really challenging, but in the end, really successful. So the main challenge to make a hydrogen transport a reality is the proper grid itself, because it is end users who are demanding a certain quality for natural gas, which in the end is a certain hydrogen level. But the natural gas grid is a big chain, and the quality of the gas at transport level has a direct impact at distribution level, and in the end in the final users. So while we can't meet the same quality for all users, which is nearly impossible, because of the different nature of the consumption of gas, we are going to have different levels of hydrogen locally in the grid. And in the end, this is going to make it difficult to get a proper regulation. But it is the challenge that we have to overcome.